become concave downwards parabola. So hence k should belong to 0 comma e square by 4. Tell me, Sarthak, you understood? Sarthak, Memel, Devang.
Understood.
Yes, sir.
Okay. See, these kind of questions can be asked in advance. Not in advance, probably in mains it can be asked. Okay. Anyways, next. Next one is y minus pi by 3
So here the slope will be half, right?
minus half. Should I solve? Tell me.
The slope part can you solve?
Okay. So in order to find out the tangent, okay,
It
I
is
need the
coming
slope.
sine inverse of sine 2 theta. So 2 tan inverse x.
Let us start. Wait. You must have got sine inverse sine 2 theta.
Yes.
Why sine 2 theta? Where what is the
Upon
value of
taking
theta?
theta equals to like x equals to tan theta.
Theta is equal to x equal to tan theta, right? Okay. Now sine inverse sine 2 theta. Okay. Where does theta belongs to? Minus pi by 2 to pi by 2, right? So 2
Yes.
theta will belong to minus pi to pi, right? So it will open with three branches. You've forgotten. Three branches, which will open with 2 theta when theta belongs to,
Minus
tell me,
2 to pi by 2.
minus pi by 4 to pi by 4, right? Tell me. Because you look at the graph, everyone. Or you can say 2 theta belongs to minus pi by 2 to pi by 2. Right, tell me. Sarthak, are you getting? You've forgotten the
Mm,
graph of sine inverse sine x graph.
the graph was like
There will be how many branches in this range? You have to also maintain the branches, right? There will be
okay.
three branches. You need to understand in which branch it will lie. So it will become 2 theta when 2 theta belongs to minus pi by 2 to pi by 2.
Pi by 2.
Yes. And it will be, uh, what is the equation of this branch? See, the equation of this branch is y equal to x. What is the equation of this branch? Tell quickly. What is the equation of the second branch? Can someone tell me? What happened? You people have forgotten
Pi
ITF.
minus x.
Pi minus x, right? So it will be pi minus 2 theta when 2 theta belongs to pi by 2 to pi.
Pi.
And what is the equation of the last branch? Tell me. Just use point slope form. Equation of a straight line minus pi comma 0. This is. Tell me.
Pi plus x.
Y pi plus x. Slope is negative now. So it will be minus pi minus x now.
Yes, minus of whole pi plus.
So it will be minus pi minus 2 theta. See, it
Mm,
is so simple. Tell me. 2 theta belongs to minus pi by 2. Right, tell me. Ondini, Devang, Sarthak, Ratim, Dabatri, Memel, Ritam. Tell me, everyone understood or not?
Yes, sir.
Yes, sir.
Yes, sir.
If you are having any doubt, tell me. I'll explain. Okay. So I've got it. Now you back substitute. Right. Back substituting, what will you get? See, if you remember the graph, I also don't know these branches. I'm telling you. I also don't remember these branches. Seriously, I don't remember. But I remember the graph. Because visually you can remember many things. Right, tell me, Sarthak.
Yes.
Visually you can remember many things. 2 tan inverse x, where x belongs to. See, if 2 theta belongs to minus pi by 2 to pi by 2, then theta belongs to minus pi by 4 to minus pi by 4.
Yes.
That means x will belong to, tell me. If theta belongs to minus pi by 4 to pi by 4, where does x belongs to? Tell me,
Minus 1 to
Sarthak.
1.
Very good. This is what I wanted to hear.
Right.
And the next one will be pi minus 2 tan inverse x when x belongs to, tell me, what is the equation of this branch? I mean, 2 theta belongs to pi by 2 to pi. So theta belongs to pi by 4 to pi by 2. So where does x belongs to?
1 to infinity.
Correct. And last one, where x belongs to minus infinity, comma, minus 1. Done. So your value that is x equal to root 3, where does it lie? Tell me, Sarthak.
1 to
Yeah,
infinity.
1 to infinity. So we are supposed to use the second branch, isn't it? Tell me. So your
Okay,
y
sir.
is
Now
equal to
understood.
rest. I think you can solve it, right? Tell me.
Yes, sir. Understood, sir. Minus half the slope.
Hmm. If anybody has any doubt, let me know. Number 5. Number 5 is 2 comma 4 and 3 comma 1. Anyone having any doubt, you can ask me. Next, number 6. Hmm. Number 6, find point on the curve. Okay. So over here, the points are 1 comma minus 2. The second point is lengthy. There will be 3 points. One is plus minus root 3, comma 1 plus minus root 3 whole cube minus 3 into 1 plus minus root 3. If you have any doubt, you can ask me. Tell me. Next is number 7. Number 7 is a proof problem. If you have any doubt, tell me. Number 7 is a proof problem. If you have any doubt, tell me. And last one is came in advance. See, advanced 2014. Okay.
How did this last question come in advance?
Huh?
How did this last question come in advance? It's so easy.
Very easy. The answer is 8, right? You people got 8. Sometimes, sometimes, see, sometimes what happens, advance also gives easy question between some tough questions. Okay. So that people are attentive while doing the paper. Okay.
Okay.
Means they also test that if a person is able to choose the right set of questions or not. Okay, choosing the right set of question is also very important in advance. Okay, in between some easy questions, in between some difficult questions, they will give some easy questions also. Okay, so people are attentive so that while attempting the question, you are not blind. You should be able to see which one is easy for you, which one is tough for you. Okay, very easy. Tell me, anyone having any doubt, you can ask me. Tell me, Raktim, Devang, those who have solved the homework questions, tell me. If you have any doubt, you can ask me. Okay, then I think we can continue. Okay, those who have not done the homework questions, try to do it and send it to me as quickly as possible. So this was the last problem we did. Length of subtangent, subnormal, rate measurement, we have done it. No. Angle between curves. We have done it. For rate measurement, we have done it. Did I explain Newton-Leibniz theorem? Tell me, everyone. Newton-Leibniz. Have I explained? Tell me, everyone.
Yes, sir, it was done.
Was done right. And there was a hemispherical bowl. That problem we did right. Hemispherical bowl.
Yes, sir.
Yes, sir.
Okay. Then in that case, we are supposed to start with monotonicity. Okay, everyone. Monotonicity, everyone. Let us start. So let us start. Monotonicity. Okay. See, monotonous means same type, means same type of function, same type of. Okay. Functions are said to be monotonic. Functions are said to be monotonic if they are if they are either increasing or decreasing in their entire domain. Okay. The functions are monotonic if they are increasing or decreasing in their entire domain. For example, y equal to e to the power x. What do you think, everyone? This is monotonic increasing or decreasing? E to the power x, ln x. What are
Increasing.
these?
Sir, increasing.
Increasing.
Increasing. Y equal to minus x, increasing or decreasing? Tell me.
Sir, decreasing.
Decreasing. Y equal to x.
Increasing.
Increasing.
Y equal to e to the power minus x.
Decreasing.
And y equal to cot inverse x.
Decreasing.
Decreasing. Very good. So Sarthak, I think you remember the graph as well. The graph
Yes,
of
sir. This one.
y equal to cot inverse x looks somewhat like this. I hope everyone remembers. It's an important graph. Okay. Next. Note everyone. Y equal to sin x is not monotonic. Y equal to sin x is not monotonic in its domain. Okay, it's not monotonic in its domain, but y equal to sin x in open interval minus pi by 2 to pi by 2 is monotonic. Okay, this is monotonic. Also, you can also say that y is equal to sin x is monotonic in close minus pi by 2 to pi by 2. Okay. Even though sin pi by 2 becomes a little bit, I mean, for a fractional point, I mean, for just one point, it becomes parallel to x-axis, but you can say that it is monotonic in the interval close minus pi by 2 to pi by 2. Next, everyone. Monotonicity of a function in an interval. Monotonicity of a function in an interval. Okay, let us define monotonicity in an interval. So everyone, if this is a curve, if this is a curve, it is monotonic increasing. Okay, let us take the neighborhood of A. Okay, everyone, this is point A. Okay, I'm going to take the neighborhood of A. Neighborhood of A means A minus H and A plus H. Okay, if you can see everyone, for some H greater than 0, for some H greater than 0, for a very small, smallest you can think of H greater than 0, if f of A minus H is less than f of A, is less than f of A plus H, we can say then the function is, then the function is monotonically increasing, monotonically increasing at x equal to A. Okay, everyone. Function is increasing monotonically, monotonically at x equal to A. And similarly, if I say f of A minus H is greater than f of A and it is greater than f of A plus H, then we can say function is monotonically decreasing at x equal to A. Tell me, are people getting? This is the correct definition of monotonically increasing function and decreasing function. Decreasing at x equal to A. Next, local maxima. Before also, in earlier chapters also, I have defined local maxima and local minima. Local maxima. So what is local maxima? Everyone pay attention. This is how the graph will look like. Okay. This is point A. For some h greater than 0, for some h greater than 0, if f of A minus h,
Sir, H is again that neighborhood.
yes, h is a very small quantity. Okay. A minus h is on the left hand side, A plus h is on the left hand side. So by looking at the graph only, you can see that f of A minus h is less than f of A, right, everyone? And it is greater than f of A plus h. So in this case, what do we say? We'll get a local, we'll get a
Maxima.
local maxima. We'll get a local maxima at x equal to. Okay, next. Similarly, we can define local minima as well. Local minima. At local minima, what will happen? The inequality will reverse. Okay, we can understand that if f of A minus h is less than, is greater than f of A, but less than f of A plus h, then we say, then we'll get local maxima at x equal, local minima at x equal to A. at x equal to a. I hope everyone has understood the meaning of local maxima and local minima. Note why local? Why do we say local? Local because there can be a lot of maximas and minimas. There can be a lot of maximas and minimas. For example, our classic example, everyone, y equal to sine x. Y equal to sine x has a lot of maximas and minimas, right, everyone? Infinitely many local maximas and local minimas. Are people getting? Tell me. Anyone having any doubt, you can ask me. Tell me, Raktim, Jawan, or Nini, Nemel, Sarthok, tell me.
Yes, sir.
Are the
Yes.
people getting?
Understood, sir.
Yes, see, we're getting a lot of local maximas and local minimas. Okay, yes. Next, we can talk about we can talk about monotonicity. We can talk about monotonicity of a function f of x at x equal to a. Okay, f of x at x equal to a. Only if x equal to a, only if x equal to a is in domain, is in domain. Okay, without any consideration of continuity or differentiability, without any consideration. Okay, means even if the function is not continuous or differentiable at x equal to a, then also we can talk about monotonicity of a function.
Sir,
Yes, tell me, Sarthak.
for a monotonous function, there will be no maxima and minima, right?
In
For a monotonous function, like will there be any maxima minima?
no, if the function is monotonically increasing or monotonically decreasing, how will you get maxima or minima?
Focus.
Okay, okay. Continuity or differentiability. Okay. See, I show you some graphs. You will understand. See, this function, everyone, is this function differentiable? Tell me, is this function differentiable at x equal to a? What do you think?
No, sir.
No. This function is not differentiable at x equal to a. But is it monotonic? Tell me, are these functions monotonic? Tell me, everyone.
Yes, sir.
Yes, of course. Because see, at x equal to a, the first function is increasing, second function is decreasing. So see, even if the function is not differentiable, then also we can conclude whether the function is increasing or decreasing. Here, both are non-differentiable at x equal to a. Where both are non-differentiable at x equal to a, but still they are, but still they are monotonous. Still they are monotonous. Okay. Next, another question. This function, what do you think? Is it continuous at x equal to a? Tell me.
No, sir.
This
No, sir.
function is discontinuous at x equal to a. But still, can I conclude that the function is monotonic? Yes.
It's not continuous, right?
Of course. Discontinuous at x equal to a. This function is discontinuous at x equal to a. Is discontinuous at x equal to a, but still increasing. But still increasing. Okay, next. This function y equal to x to power 1 by 3. Okay, this is not differentiable at x equal to 0. Right, tell me. Not differentiable at x equal to 0, but still increasing. Okay, so it does not matter whether the function is differentiable or continuous at a point or not. The function can still be, we can still conclude that the function is increasing or decreasing. Next, monotonicity in an interval. Monotonicity in an interval. Okay, if function at all points, if function at all points in open a comma b is monotonic, monotonic, then f is monotonic. Then f is monotonic in the whole interval. The whole interval open a comma b. Okay, next. So everyone, if dy by dx is equal to 0, this does not implies maxima or minima. Okay, this does not implies maxima or minima. You have to check it through graphs only. Okay, you have to check left hand limit, you have to check the right hand limit. Okay, So I'll show you some examples. Number one, y equal to x cube. Can someone tell me over here, in this case, y equal to x cube, in this case, okay, what is the derivative at x equal to 0? Tell me.
0.
0. But can I say that we are getting maxima or minima at 0? Tell me over here. It is strictly an increasing function, right?
Yes.
It's an increasing function. Okay. Next, number two, let us talk about y equal to minus x. Y equal to minus x cube over here. Okay. Over here also the derivative is equal to 0. Over here we can say it is strictly a decreasing function. Decreasing function. Next, number three. But sometimes you can get y equal to x cube, 0 at x equal to 0. You can get local minima as well. Here we are getting local minima. Okay, so that is why you have to check LSD and RSD to understand whether you will get local maxima, local minima or not. Okay, here we are getting a local minima at x equal to 0. Next, number four. Over here we are getting a local maxima at x equal to 0. A local maxima at x equal to 0. Okay, tell me. But still, see, in all four graphs, the derivative at x equal to 0 is 0 only. Right, everyone? Tell me. If you find out the derivative at x equal to 0 for all functions, you will get 0 only. But still, in some cases, you might get local maxima, local minima. In some cases, you may get neither. Okay, okay. Next, over here, mm, f of x equal to x cube. If you find out the derivative, f dash x will be equal to f dash x will be equal to 3x square. Okay, f dash x is equal to 3x square. What is f double dash? Okay, okay. F double dash x. It will be equal to 2x. Can you people see f double dash x is greater than 0 for x greater than 0 and f double dash x is less than 0
So it
when
is
x is
6x,
less.
right? Double dash it.
6x. Sorry. 6x. Now my point is, see, over here, f double dash x is greater than 0 for x greater than 0 and less than 0 for x less than 0. So see, the concavity is changing, right? Before 0, okay, before 0, the function is concave downwards. After 0, the function is concave upwards. That is why you are not getting over here a local maxima or local minima. Okay, the concavity of the graph is changing. That is why you are not getting a local maxima or local minima. But see, over here in the third and the fourth graph, the concavity remains the same. If it is concave upwards, it is concave upwards. If it is concave downwards, it is concave downwards. Okay. Tell me, anyone having any doubt, you can ask me. Okay, next. Question number 1. You people have to tell me, raise your hand, okay? Over here, are we getting local maxima or local minima? You have to tell me. Okay, everyone? Okay, these are some conceptual based questions. You have to tell me over here we are getting local maxima or local minima. Yes, on any tell me. On anything. Over here we are getting local maxima or local minima or nothing. What is it?
Sir, nothing.
Nothing. Okay. Next is Raktim. Tell me. What do you think?
Sir, minima.
Minima. Okay. So one person has said nothing, another said local minima. Sarthak, you tell me.
Local minimum.
Local minima. Sarthak has said local minima. At x equal to 0, we are talking about. Okay. Anyone else who wants to answer? Okay, or Nini, you want to change your answer?
Yes, sir, local maximum.
Local maxima. Okay. So only has changed it to local maxima. Anyone else who wants to answer? Devatri, Memel, you people want to try? Rhythm, you want to try? Tell me. Okay. So Onini, finally you are correct. Over here we are getting local maxima at x equal to 0. Why local maxima over here? You can see that over here f of 0 minus h is less than f of 0 and it is greater than f of 0 plus h. Tell me, are you getting Sarthak, Raktim,
Can you
Onini?
explain this one?
Yes, you see, f of 0 is this, f of 0 minus h is over here, na?
Oh, okay, sir. Understood.
F of 0 plus h is over here. Can you see? So over here at x equal to 0, we are getting local
Maximum.
maxima. Therefore, here we are getting, right, Devatri, are you getting? Devatri, Memel, Ritam,
Yes.
Devang,
Yes, sir.
Devang, are you getting
Yes, sir.
at x equal to 0? Next, number 2. Number 2, I'll post another graph. You people have to tell me. Local maxima or local minima? Tell me. Yes. So this one is, okay, Sarthak, tell me.
Local minimum.
Local minima. Very good. Yes. Memel, you are not answering any question. You didn't understand the meaning of local minima, local maxima. Tell me.
No, sir, I am also thinking local minimum only.
So you have to speak up, right? And Devatri, you understood everything? Tell me, Devatri, Devang, if you all understood.
Yes, sir.
Yes, sir.
Oh, next one, I'm showing another graph. Try to identify those who are not yet trying. I mean, try it out. Everyone should try. These are very simple conceptual uh, problems. Think about it. Take your time. You have to tell me whether these are whether at x equal to a you are getting local maxima or local minima. This is point A. Okay. Identify. Tell me. Raise your hand. Over here you are getting local maxima or local minima. Everyone should try. Okay. Let's see who has raised the hand. See, I see the same hands. What about others? Okay, that's the you tell me.
The maximum.
Hmm. Local maxima, right? If you are not getting, tell me, I'll explain. Memel, Devatri, Devang, if you people have not understood rhythm, tell me, I'll explain. Okay. So the next one will also, next one I'm again going to show number four. In this case, local maxima or local minima. Raise your hand. Tell me. I see the same hands. Okay, on any you tell me.
Local minimum.
Local minima. So I hope the definition is clear to everyone. Memel, are you following? Yes or no?
Yes, sir.
Note. If a function has extremum at x equal to a, if a function has extremum, so this is what we were talking about, Sarthak. Extremum means local maxima or local minima. Okay, local
Okay, sir.
maxima or local minima. Okay, at x equal to a, then it can't be monotonic. Then it can't be monotonic. You cannot say it's a monotonic function at x equal to a and vice versa. Okay, next. Just give me 1 minute. Oh, it can't be monotonic at x equal to a. Okay, number two. If f is increasing, if f is increasing, nothing definite can be said. Nothing definite can be said, can be said about f dash x being monotonic. Okay, nothing definite can be said about f dash x being monotonic. Number three, the definition of increasing The definition of increasing is if x1 is greater than x2, it will imply f of x1 greater than or equal to f of x2. Okay. For example, I show you a function. Okay. In this interval, the function becomes horizontal, but still will say that the function is increasing. Are people getting? Okay. This is a B. Here, f of x is still, here f of x is still increasing. Though it becomes horizontal, though it becomes horizontal in open A comma B. Okay. Next. So everyone, let us do another problem. Question number 2. A function is increasing in open 0 comma 1 and decreasing in 1 comma 2. Okay. Then it has option A, local maxima at x equal to 1. Option B, local minima at x equal to 1. Okay, once you've done it, send your answer, okay? You will get only one chance because I'm giving options. Local minima at x equal to 1. Option C, nothing can be said. Okay, nothing can be said. Option D, what to say? Option B, option D, what to write?
Sir, can you just write the correct option in the chats?
In WhatsApp, you write it. Okay. Option D, it will snow today in Kolkata. Okay. Send. Okay. Sarthak, Raktim, Andani, check your answers again. Devang, check your answer again. I'm waiting. Nimel, Debatri, send your answers. Yes, okay, only now it is correct. The Battery, check your answer again. Memel, I'm waiting. Memel, Ritam, I'm waiting. Raktim, your answer is correct. Yes, Memel, what are you doing up behind the screen? Are you doing something else? Memel, check your answer again. And Ritam, what happened? Don't want to answer.
Thanks, sir.
Sir, it is taking time, like I'm thinking, then sending. So,
Sure. Okay, anyways, Ritam, also check your answer again. Devatri, now it is correct. Yes, Athok, now it is correct. So everyone pay attention. I'll give some counter example, okay? Yes, maybe it is correct. The answer should be option C. Okay. Nothing can be said. Nothing can be said about f of x at x equal to 1. Why? Because you see, case 1, it can happen like this, right? At x equal to 1, see, from 0 to 1, it can be increasing like this. Okay. The function can be discontinuous. If it was a continuous function, then you can say, if it was continuous function, then you can say something. From 1 comma 2, it can go like this. Okay. And at x equal to 1, exactly 1, the point can be over here. Okay, you can get a local minima. Next, case 2, it can be somewhat like this.
The point can be above both.
Point can be above both. Correct. Tell me, are you people getting? Tell me, Ritam, you understood? Ritam, Devang, everyone understood? Tell me.
Yes, sir.
Yes, sir.
If there's anyone having any doubt, you can ask me. Note. Okay, what is the meaning of strictly increasing or monotonically increasing functions? Okay. But see, IIT has never made any difference between these two definitions. Okay. But for NCRT, okay, this is the difference between strictly increasing or monotonically increasing. Okay, everyone. But in IIT, they will never confuse you between definitions. Okay. Monotonically increasing. If x1 is greater than x2, x1 is greater than x2, this implies f of x1 is greater than f of x2. Okay, everyone. Note, according to IIT, according to IIT, increasing and strictly increasing are same. Increasing and strictly increasing are same. The difference between the definition occurs in NCRT. Okay.
So, sir, in the boards, the both will be different.
Yes, they will expect you to write different answer. Okay. Increasing means you have to write greater than or equal to. Strictly increasing means only greater than. Okay. Similarly, similarly, if x1 is greater than x2, implies f of x1 is less than f of x2, means f of x is decreasing. Okay, everyone. Of x is a decreasing function. Next, there are some definitions which you people should remember. Turning point. What is the meaning of turning point? See, turning point means at the turning point, at the turning point, by the name itself, you can understand that at the turning point, you'll get a maxima or a minima, right? You'll either get a maxima or a minima. Okay. You either get a maxima or a minima. Next, stationary point. Stationary point. Okay. A is the stationary point. A is known as the stationary point. Stationary point of f of x if f dash a is equal to 0. Okay, if you find that f dash a is equal to 0, then a is the stationary point of f of x. Next is critical point. Critical point. A is the critical point. A is the critical point of A is the critical point if f dash a is equal to 0, if f dash a is equal to 0, or f dash a is not defined. Okay, in both the cases, you can say A is the critical point. Okay, because that will decide the nature of the graph. Note number one, for a differentiable function, for a differentiable function, if the sign changes, if the sign changes of dy by dx, okay, there is a sign change of dy by dx, then y has a turning point. Then y has a turning point. Okay, that is y has a local maxima local maxima or minima. As a local maxima or minima. Number two. See, we cannot say, we cannot concretely say whether a function, say whether a function is increasing when dy by dx, when applying dy by dx is greater than 0 or dy by dx is greater than or equal to 0. Okay, we cannot concretely say. Why? For example, you see y is equal to x cube. This implies dy by dx is equal to 3x square. So everyone, 3x square is greater than 0. Where is it greater than 0, everyone? Tell me. This implies x belongs to. What is the solution of this inequality? Tell me. Raise your hand. If I'm writing y is equal to 3, y dash is equal to 3x square greater than 0, what is the solution of this inequality? Tell me. Yes, Arthur, tell me.
R minus 0.
R minus 0. All real numbers except 0. Okay, except 0. Elemental 0. Okay. But you see y equal to x cube increases for all x belongs to R. Okay, everyone. Y equal to x cube increases for all x belongs to R. Is increasing for all x belongs to R. Okay. So dy by dx. So dy by dx greater than 0 does not ensure us, does not ensure us about increasing of a function, about increasing of a function. Again, for the constant function, for the constant function, y is equal to 3, you will get dy by dx is equal to 0. Okay, and 0 is, we can say 0 is greater than or equal to 0. But tell me, everyone, is the function increasing? No, right? So it does not ensure us whether a function is increasing or decreasing. Okay,
So, sir, how
so
can we say about that increasing or decreasing by the graph?
yes, with the help of a graph, you have to understand whether a function is increasing or decreasing. Okay, also, see, whenever a function is given to us, okay, you need to understand that the function does not becomes a constant function at any point. Are you getting? If you can understand that the function does not becomes a constant function at any point, okay, and then you apply dy by dx greater than or equal to 0, then you will get exactly the intervals where the function is increasing or decreasing. Understood? Like for example, y equal to ln x. Uh, okay. Y equal to ln x. Y equal to ln x. So you can understand that y equal to ln x will never become a constant function, right? So if you apply y dash is equal to 1 by x. See, 1 by x is greater than or equal to 0. Greater than 0, always increasing, right? Greater than 0 for all x greater than 0. Okay, hence this function is increasing for all x belongs to real. Are you getting? Tell me, Sarthak. So you just need to
Yes, yes.
ensure that the function is not a constant function. Okay. Next. So dy by dx is greater than or equal to 0. Also does not ensure. Also does not ensure us about the increasing of the function. About the increasing of the function. Okay. Thus to check whether a function is increasing or decreasing. Thus to check in order to check whether a function. Tell me, Devang, are you getting? Devang,
Yes, sir.
Tebatri, Memel, Ritam, are people getting?
Yes. Yes, sir.
Is increasing or not? We need to check. We need to check two things. Number one, dy by dx is greater than or equal to 0. Number two, y is not a constant function. These are the things we need to keep in mind. Tell me, anyone having any doubt till now, you can ask him. I'll explain. Tell me, everyone. Anyone having any doubt? So I think we can do some problems. Okay, everyone. Let us start with some problems. On any, you have any doubt? Tell me.
No,
On
sir.
any, Sarthak, Devang, Dakim, Memel,
No, sir.
Ritam, Devatri, you people have any doubt? Tell me.
No, sir.
Then I think we can continue. Question number one. Let us start. Find the interval of monotonicity. Okay, question number one. Find the interval of monotonicity of monotonicity of the following functions. Of the following functions. Number one, x square into e to the power minus x. Number two, 3 cos to the power 4x plus 10 cos cube x plus 6 cos square x. See, these type of questions are very much important for JEE. Okay, you see PYQs, you will understand in 0, comma pi. Solve. Question number 3. As you know, question number 2. If f of x equal to ax minus sin x, find a if the function and a if the function number 1 has no critical point, has no critical point. Number two is monotonic. Quickly solve, everyone. Question number three, f of x equal to sin x minus a sine 2x minus 1 by 3 into sine 3x plus 2ax is monotonically increasing. Increasing for all x belongs to real. Find a. Solve, everyone. Okay, so some people have sent the answer. Let me check. Okay, Sarthak, when I'm writing interval of monotonicity, that means you have to write where it is increasing, where it is decreasing. You have to mention.
Sir, 1 minute continue.
Okay, Devang, your answer. I mean, question number one is correct. Number two, No, Devang, one part one, you are making some mistake. Yes, Memel, your answer is correct.
Should have sent it one.
Checking, checking. Devang, part two is also correct.
Sir, in one part one, is there a mistake in the brackets?
In one part one, you didn't include the critical points, so you have to include it somewhere. Are you getting? In
Okay,
one
sir.
part one, see 0 and 2 you have excluded. You have to include it somewhere. Are
Oh,
you
yes,
getting?
yes, yes. Yes, I made a mistake in the brackets.
Yes. Okay, what about others? Only Devatri, everyone send your answers. Memel, number two is also correct. Number one is also correct, but again, you also didn't include the critical points, that is 0 and 2. Somewhere you have to include it, right? 0 and 2.
Yes, sir.
Okay. Again, for Ritam also, you have to include the critical points somewhere, right? Either in increasing or decreasing, you have to include it. The Batri right answer. The Batri, if you are including it in increasing part, you have to exclude it in decreasing part, critical points. Right? Don't include in two places.
So the two, right? Then it will be
Two
open bracket.
and in decreasing, just write it open. In increasing, just write closed.
Okay, sir.
Okay, who else is left? Let me see. Only
I gave the answer part one.
Only yes, I'm checking. Yes, only your answer is correct. Okay, Sarthak. No, Sarthak, you are making some mistakes. So, Sarthak, pay attention. I'm solving, okay? Sarthak, what have we got? We have to find out the interval of monotonicity for one part one. Pay attention. So, let us start, everyone. Okay, I'm going to solve one part one. Okay, I'm going to also draw the graph. I show you how we can draw the graph of these kind of functions. Okay, x square into e to the power minus x. Pay attention, everyone. So, over here, can you people understand? Uh, this function cannot be a constant function. Can this ever be a constant function? Tell me, everyone. Tell me, can this function ever be a constant function? No, right? What is the domain of x square into e to the power minus x? Tell me, what is the domain? Is all real, right? Hello, are you
All
people
yours.
there? Is all real. Okay. Next, you can understand that if you put, if you find out f of minus infinity, f of minus infinity will get limit x tends to minus infinity. Okay, x square into e to the power minus x. This will give us infinity into infinity, which is infinity only, right? So at minus infinity, you'll get infinity. I hope you people can understand. Number two, let us see what will happen at infinity. F of infinity will be equal to limit x tends to infinity. It will become x square by e to the power x. That is infinity by infinity form. So we have to find out the limit using L'Hopital rule. We can use L'Hopital rule over here. Okay, let us differentiate. On differentiating twice, what are you getting? Limit x tends to infinity, 2 upon e to the power x, which is equal to 2 upon infinity, which is 0, right? So I've got 0 over here. So I can say f of x is differentiable. F of x is differentiable. Wait a minute. F of x is differentiable and continuous. Now we have to find out where it is increasing, where it is decreasing. Okay, putting dy by dx greater than or equal to 0. Okay, what are we getting? This implies minus x square into e to the power minus x plus 2x into e to the power minus x must be greater than or equal to 0. So if you take e to the power minus x common, what are we getting? We'll get x into x minus 2. This should be greater than or equal to 0. E to the power minus x is anyways greater than or equal to 0. So we have to find out the critical points. We have to use VE curve to solve this inequality. Right, tell me, Sathok, are you getting?
Yes, I did this only.
Did this only. Actually, see, it should be 2x minus x square. So inequality sign will reverse.
Okay, sir. That's what I'm looking.
So this is how the graph is going to look like. So over here, what is the solution? X belongs to close 0 comma 2, right?
Zero
Tell
to
me.
two.
So over here, the function is increasing. If the function is increasing in this interval, in the rest of the interval, it will decrease, right?
Yes.
Okay. This implies the function f of x is decreasing is decreasing in minus infinity comma 0 union 2 comma infinity. Okay. Now let us find out the values at some critical points. Let us find out the value at 0. F of 0 is equal to 0. F of 2 is equal to f of 2 is equal to 4 by e square. Okay. And we already know the value at minus infinity and if infinity. So how will the graph look like? The graph of the function will look somewhat like this. It will come from infinity, rich origin. Okay. Up to origin, it is decreasing. Okay. Then it will start increasing. Are the people getting? It will start increasing like this. Are the people able to understand or not? Tell me.
Yes, sir.
And then again decrease up to infinity. This is how the graph is going to look like. Anyone having any doubt, you can ask me. I'll explain. Okay. Next. So over here, at x equal to 2, we are getting a maxima. At x equal to 0, we are getting a minima. Right. At x equal to 2, the point is 2 comma e square by 4. Now, related to this, there can be some questions asked. You people tell me. Okay, number one. I mean, you have to find out lambda. In the previous question, find lambda. If x square into e to the power minus x equal to lambda has number one, zero solutions. Number two, one solution. Number three, two solutions. Number four, three solutions. Yes, start telling me everyone. For number one, raise your hand. What is the answer? Raise your hand. Can someone tell me? Do people remember how to solve this kind of questions? Oh, you people have forgotten how to solve this kind of questions. X square into e to the power minus x equal to lambda. How to solve this kind of question? We used to draw the graph of the left hand side and we used to draw the graph of the right hand side. So how does the graph of y equal to lambda looks? Tell me, anyone?
Straight line parallel to x-axis.
Straight line parallel to axis. So there will be a lot of lines, right? A lot of parallel straight lines. Okay, that you can draw. A lot of parallel straight lines. You have to tell me which straight line, which straight line. The intersection point will give us the solution, right? So for number one, can anyone tell me the solution now? Now so it's easy. Raise your hand. For number one, tell me. Yes,
So there
Ratin,
will
tell
be
me.
some range of lambda.
Of course, of course.
Sir, lambda less than 0.
Lambda less than zero. Very good. Lambda belongs to 0 comma infinity. Sorry. Minus infinity comma 0. Right, tell me. Memel, Onini, Jabatri. If you people didn't understand, you ask me. I'll explain again. Tell me. Ritam, Sarthok, Devang, tell me. If you people haven't understood, you ask me again. I'll explain. Tell me. Tell me. Ritam, Debatri, Memel,
Yes.
Onini,
Yes, sir.
Sarthok, everyone
Understood,
understood,
sir.
right?
Yes.
Sarthok, you understood?
Understood, sir.
So tell me, if you people have understood, somebody tell me for this one, x belongs to, sorry, lambda belongs to, yes, for this one, Debatri, tell me.
So for one solution, that one, right?
Hmm. For
So,
one solution.
sir, it will be minus infinity to 0 union 4 by e squared to infinity.
Wait, I wrote e square by 4, right? By mistake, it should be 4 by e square. Go and tell me what were you saying?
So, it should be equal to 0 or greater than 4 by e square.
Okay, so lambda belongs to 4 by e square comma infinity and union
Um, yes, sir, union 0 to minus infinity.
0 to means minus infinity to 0.
Minus infinity to 0, yes, sir.
But from minus infinity, if you draw the lines, are they intersecting the graph at any point? Tell me.
No,
Tell
sir,
me.
then. So
No,
it should
right?
be just elemental 0.
Just elemental zero. Correct.
Yes.
Very good. Just elemental zero. Next, number three, two solutions. Raise your hand. For this one, Sarthak, tell me.
So 0 to 4 by square.
0 to 4y square. So you mean to say that these straight lines are intersecting the graph
Oh, it is
at
thrice. Sorry.
guys, no? Tell me. Okay, maybe you tell me.
Sir, equals to, like
Equal
equals to 4.
equals to what? Tell me.
Sir, 4 by square.
4y square, correct. And last one, three solutions. Okay, Raktim, tell me.
So 0 comma 4 by e square.
0 comma 4y square. Tell me the brackets.
So they are not included.
Correct. Has everyone understood? Tell me. Very
Sir, in
simple.
the
Sir,
last,
may I explain the third part?
Third part. Yes. Third part means two solutions, right? So you need to find a straight line which will intersect the graph at only 2 points.
Okay, sir, understood. Like at 4 by square. Okay.
Hmm.
sir, can I explain the fourth part once?
Yes, you need to find out such a value. It's not k, it's lambda. You need to find such a value of lambda which will intersect the graph at three distinct points. Okay, like see these ones. See, it is intersecting the graph at three distinct points. Can you understand?
Yes, sir.
Okay. So see, it should range from open 0 to 4 by e square open. Are you getting?
Yes, sir.
Okay. See, these kind of questions can be asked in JEE. Next, part 2. Should I solve, everyone? Let me solve part 2. Okay, I think Devang, you have sent something. Let me see. Yeah, Devang, you're making some mistake in number 3. Yes, Sarthak. No, you're making some mistakes. Sarthak, differentiate. You'll
So
get the
after
result.
differentiating,
Put it greater than or equal to 0. Right, and then you find out the interval. Right, you'll get a trigonometric equation. Okay, let us start part 2. Okay, everyone. So in part 2, again, everyone, I have to differentiate. We'll get a trigonometric equation. Are you getting Sarthak? See, everyone pay attention. Sarthak, Davatri, Memel, pay attention. Part 2. So over here, what you do is you differentiate. Okay. Over here, the domain is all real number. Okay. I mean, it is given in 0, comma pi. You have to substitute only 0 to pi. What is f dash x? F dash x will be equal to 12 cos cube x into minus sin x plus 30 cos square x into minus sin plus 12 cos into minus sin. Right, tell me. You have to put it greater than or equal to 0. Tell me, Sarthak, are you getting?
yes, sir. Got the value this, but
But after this, you have to take common, right? You see, you take minus 6 sine cos common. 6 is common in all of them. What are you getting? You'll get a quadratic, you see. You'll get 2 cos square x plus 5 cos x plus 2. Tell me, are you getting Sarthak? You have to put it greater than or equal to 0. After this, you have to, factorize. You can factorize it. What will you get? You will get 2 cos x plus 1 into cos x plus 2. This is greater than or equal to 0. Now, in 0 to pi, cos x plus 2 is always greater than 0. Right? It is always greater than 0. Whatever you substitute, it is greater than 0. It does not matter. Next, sin x is also greater than 0. Okay, in 0 to pi, open. Okay, so we don't need to think about these two expressions. We just need to think about cos x and 2 cos x plus 1. Okay, now Sarthak, tell me in 0 to pi, if I put 2 cos x plus 1 equal to 0, what is the value of x? Cos x equal to minus half, right? What is the value of x? Tell me. If cos x is equal to minus half, what is the value of x? Tell me, Sarthak.
2 pi by 3.
2 pi by 3, right? So, before 2 pi by 3, what is going to happen? Tell me. This is 2 pi by 3. Let us see the sign change. See, before 2 pi by 3, just before 2 pi by 3, and for cos x equal to 0, you'll get pi by 2, right? So there are two critical points. Now, before pi by 2, you can understand cos x is positive, and 2 cos x plus 1 is also positive. So the whole expression is positive, but ultimately the expression will become negative. So before pi by 2, it is negative. After pi by 2, it is positive. Then it is negative. Right. Are you getting
Can you
Sarthak?
explain this
Therefore,
concept in the last part? The sign change.
yes, before pi by 2, cos x is positive.
Positive.
2 cos x is plus 1 is also positive, right?
Okay,
So
sir.
this whole expression is positive. This whole expression is positive. Right, tell me, before pi by 2.
Yes.
Okay. But due to this negative sign, it will become negative, right or not? Tell me, Sarthak.
Okay, sir. Understood, sir.
And between pi by 2 to pi by 3, what will happen? It will become positive, right? Because cos will become negative after pi by 2. Okay. So it will become positive, then it is negative. Okay. So what are you getting? Therefore, f is decreasing in close 0 to pi by 2 union to pi by 3 to pi. Tell me, are you getting? And if I want to write increasing, f is increasing in pi by 2 to 2 pi by 3. Open, open. Is it clear, Sarthak?
Understood, sir.
Okay. If I want to draw the graph, okay, sometimes they will ask you the range of this function. So you have to draw the graph of this function. So in order to draw the graph of this function, you know where it is increasing, where it is decreasing. You just find out the values at some critical points. What is f of 0? Tell me, Sarthak. Sarthak, you tell me f of 0. Memel, you tell me f of pi by 2. Only you tell me f of 2 pi by 3. And Devang, you tell me f of... Uh, no, no. Oh, this much only. So Devang, wait for something. So tell me, Sarthak, you tell me f of 0. Memel, you tell me f of pi by 2. And Only you tell me f of...
As for that question, you answered the expression.
You didn't copy the
I
expression.
directly wrote the detail. So f
Sir,
of 0 is 16.
F of 0 is
16.
16. Yes, tell me. I'm waiting. Nemel, tell me what is the value of f of pi by 2. Nemel, are you there? Okay, she has slept. Okay, only you tell me f of 2 pi by 3.
Yes, sir, I'm telling. Just 1 minute.
Achha. So Nemel, only you tell me f of 2 pi by 3.
So 1 minute. Sir, minus 29 by 16.
Minus 29 by 16.
Sir, minus 41 by 16. Sir, you
Why?
said for me f of pi by 2.
Yes. Why you people are... Acha, tell me, f of 2 pi by 3, how much you got?
Sir, 2 pi by 3 minus 41 by 16. Sir,
Okay.
minus 3.
And f of pi by 2 is minus 3. Okay. Okay. So let us draw the graph. The graph will look somewhat like this, right? Tell me, everyone. The graph is... And what is f of pi? Okay. So, Devang, you tell me what is f of pi? What is the value?
Minus 4 f got.
How much you got, Devang?
Sir, same answer.
Okay. So see, this is how the graph is going to look like, everyone. Are people getting? See, drawing the graphs are very important. If you are unable to draw the graphs, it will be difficult to attempt good questions in exam from AOD. Okay, everyone. This will be minus 3. Okay. 0. This is pi by 2. This is 2 pi by 3. And this is pi. Okay. So can someone tell me what is the range of this function? Can someone tell me what is the range of this function? Tell. Yes, Raktim, tell me range of this function.
Minus 4 to 16.
Minus 4 to 16, closed. Tell me. Sometimes they can ask you the range of the function also. So this can be done through finding the critical points, values at some critical points
Guys, for
only.
the solution one second, I have a doubt. Like one.
Tell me, Sarthak, what doubt you have.
So if I scroll up once, no, sir, it's okay, sir.
Okay, solve everyone. Number 2. Cos x. Sarthak, what are you writing? The answer shouldn't be in terms of cos x, no?
Okay, sir.
Okay. Number two. Oh yes. Yes, the Batri right answer. Okay. So Sarthak, pay attention. Over here, it has no critical point, right? Tell me. Over here, what is the first part? It has no critical point. When can we say that a function has no critical point? When the derivative of the function is equal to zero or the derivative does not exist. In these cases, okay. So see, ax minus sin x is differentiable.
It will be minus 1 to 1. Close, open, close, close.
Minus, no, no, no. Is differentiable always, right? So df by dx should always exist. Df by dx should always exist. So using the first condition only, that is the derivative is equal to zero. D by dx of ax minus sin x will be equal to a minus cos x, which is equal to zero. This implies cos x cannot be equal to. So from here, what do we see? If the function has a local maxima, I mean, if df by dx is equal to zero, that means a will be equal to cos x. This implies cos x should not be equal to a, right? That means a should be outside the range of cos x. Therefore, a
So
belongs to
why?
minus infinity comma minus 1 union 1 to infinity. Are you getting?
Yes, sir. Understood.
So why not equal to?
Not equal to. Not equal to. Understood. Tell me.
Okay, sir. So for it should be not equal to 0 for no critical point.
Yes. Is it clear?
Sir, but sir, you wrote in the first line df by dx equal to 0.
No, actually, I changed it to not equal to zero. Okay. Is it clear?
Okay, sir. Now understood.
Then only it does not have a critical point. No? Number two, it is monotonic, right? So it is monotonic if df by dx is greater than or equal to zero or df by dx is less than or equal to zero. Now see, over here, a minus cos x cannot be a constant function. Constant function. Okay. Which is not possible for any constant a. Okay. So a minus cos x must be greater than or equal to zero, or a minus cos x must be less than or equal to zero. Okay. This implies a can be greater than or equal to cos x or a must be less than or equal to cos x. Okay, so this implies a should belong to minus infinity to minus 1 closed union, closed 1 to infinity. Tell me, Sarthak, are you getting? Sarthak, Devank, Onini, Rakti, Mimel, are people getting? Yes or no?
Yes,
Tell
sir.
me.
Yes, sir.
Okay, so note, I'm also going to draw the graph of this function. See, drawing the graph of drawing the graph when a is equal to 1. Okay, the graph of f of x equal to x minus sin x. Okay, everyone. I'm going to draw the graph of this function. Over here, what is the domain, everyone? Domain is all real. Okay, f of infinity is infinity only. F of minus infinity is minus infinity only. Okay, so range will be all real. What is the derivative? Derivative is equal to 1 minus cos x. Okay, if you put it equal to 0, where is cos x equal to 1? Tell me, everyone. Where is cos x equal to 1? Tell me.
So 0.
Only at 0, at 2 and pi, right? The derivative, because is it equal, derivative is equal to 0 only at 2 and pi, right? Tell me. Okay. And for x equal to, so that means at x equal to 2 pi, at x equal to 2 pi, the function will just become flat for a fraction of a second. It will just become flat, and then again it will keep on increasing. Okay. Also, if you find out the double derivative, d2y by dx square. Okay, if you find out the double derivative will be equal to what? Tell you, it will be sin x, right? Tell me, everyone. Double derivative is equal to sin x. Okay, so what you do is you can see around 2 pi d2y by dx square is greater than or equal to 0 when x is greater than or equal to 2 and pi for all n belongs to natural numbers. Or you can say for x greater than or equal to 2 pi, greater than 2 pi, greater than or equal to 2 pi. And it will be less than or equal to 0 when x is less than or equal to 2 pi. Right, everyone? So around 2 and pi, the function changes its concavity. Right, everyone? Tell me. Around 2 and pi, the function changes its concavity. That means over here, are you people getting? Yes or no? If you're unable to understand, you can ask me. Tell me. At exactly 2 pi, the function changes its concavity. Yeah, I'll plot this function on Desmos also to explain. Fine. Tell me, everyone is getting how I'm drawing the graph. If you're not getting, you ask me, I'll explain. Tell me, the battery, are you getting?
Yes, sir.
Okay, this is how the graph is going to look like. So for x equal to 2 pi, uh, for x equal to 2 pi, what is the value of y? Tell me, Sarthak, what is the value of y? X equal to 2 pi. Yes, tell me.
So 2 pi. So 1 minute. It is 16.
If x equal to
So
2
so
pi,
1 minute. So 1 minute. So 1 minute.
yes, I think I've drawn the graph of x minus sine x, right? Tell me, why is it taking
So
so much time?
A into 2 pi.
Acha, tell me, what graph I have drawn over here? Which graph I'm drawing over here? Tell me, Sarthak.
X minus sin x.
X minus sine x, right? Memel, are you there? X minus sine x. If I want to
Yes,
find
sir.
Y
out
equals to 2 pi only, sir.
y is equal to 2 pi, it will be 2 pi only, right?
Yes, sir.
So why is it taking so much time? I cannot understand. Okay. So over here, there will be, I mean, see, you can also understand that d2y by dx square, it is just like, it is changing its sign around x equal to 2 pi. So x equal to 2 pi is the point of inflection, right? It implies x equal to 2 pi is a point of inflection. And if I want to, and there will be how many points of inflection, everyone? Tell me. There are how many points of inflection? Infinitely many, right? There are infinitely many points of inflection. Points of inflection like this. Tell me, Mimel, Devang, Raktim, Mandini, Sathok, are people getting? There will be infinitely many points of inflection. Yes. Okay. Next, if I want to write down the equation of tangent, okay. If I want to write down the equation of tangent, how do I write down the equation of tangent? Tell me. We have to find out d2y by dx square to write, I mean, to draw the equation of tangent, or you can say to write the equation of tangent at point of inflection, at of point of inflections, points of inflection. First of all, you need to find out those points of inflection. Okay, d2y by dx square should be equal to 0, and d2y by dx square will change its sign. We change its sign. Okay. Next. So over here, what is d2y by dx squared? Over here, what is d2y by dx squared? D2y by dx square will be equal to sine x. And where does the sign changes? D2y by dx square will be greater than 0 when x is greater than 2n plus 1 whole pi. And it will be less than 0 when x is less than 2n plus 1 whole pi. Okay. So let us write down the equation of the tangent. So what is y dash at pi? What is dy by dx? We have to find out the slope and point, right? Dy by dx at x equal to pi will be 1 minus cos pi. Cos pi is minus 1, so we'll get 2. Therefore, equation of tangent. Are people getting? I know the point. I know the slope. Equation of tangent will be, equation of tangent is y minus y1. Y minus y1. Wait a minute. Y minus y1. Y minus pi is equal to 2 into x minus pi. Tell me, is it clear to everyone? Are you people getting yes or no? Acha, everyone, x equal to pi is a point of inflection, right? So I think this point, when I drew the graph, this point will be pi comma pi. Okay, this is the first point. Okay, pi comma pi. Tell me, Memel, Onlini, Devatri, Devank, and Taktim, is it clear?
Yes, sir.
Okay. Anyone having any doubt, you can ask me. Devatri, you understood? Tell me how I have found out the point
Yes,
of
sir.
inflection and I have drawn the graph. Let us see whether the graph is correct or not. It was f of x equal to x minus sin x. See, you should be able to understand how to draw the graphs. Okay, it is very important for advance. See, everyone, we have drawn the graph correctly only. See, are you people able to understand? See, first of all, the function is, first of all, the function is increasing. I mean, it is concave upwards up to 2 pi. Then it is concave downwards, then upwards, then downwards. Wait a minute. At pi, the concavity does not changes. So that means I have done some mistake or what? Oh no, no, it changes. It changes. Try to understand everyone. It changes. Up to pi, it is concave upwards. Okay, everyone see. Up to pi, up to 3.14. The function is concave upwards. 3.14. It's concave upwards. Then after 3.14, it's concave downwards, then upwards, then downwards, then upwards. Are people able to understand? If you are having any doubt, you can ask me. Next. Devang, understood?
Yes, sir.
Okay. Quickly solve the next one, everyone. Third one, quickly solve. On any you understood? Tell me.
Yes, sir.
Okay, third one everyone solved. Devatri, you understood how I drew the graph?
Yes, sir.
And Devang, you understood?
Yeah, I understood.
Okay, solve the third one.
So I sent you the third one.
Okay. Yes, Memel, is it done? Tell me.
Sir, sending.
Okay.
Sir, I've sent.
Checking. Yes, Memel, your answer is correct. Devatri, your answer is correct. Rakti, you are making some mistake. Only your answer is correct. So, Rakti and Sarthok. Sarthok, I'm solving. Rakti and Sarthok, pay attention. Same thing, everyone. What you have to do? You have to just differentiate. It's monotonically increasing, right? Just have to put f dash x greater than or equal to 0. That's it. Nothing else. Every time you have to do the same thing. This is number 3. Put f dash x equal to cos x minus 2a sine 2x. Sorry, minus 2a cos 2x minus 3 by 3 cos 3x plus 2a. Tell me. Sathok and Raktim, are people getting? Yes
Yes,
or
sir.
no? Now you have to simplify, right? Now, what is sine? Over here, if you simplify,
Sir, I kept C cos x and cos 3x in the left side and 2a cos 2x and 2a on the right side.
correct, correct, right. So cos x minus cos 3x, we can use C and D formula, right?
Yes, sir, then I did that.
2 sine C plus D by 2, that is 2x into sine D minus C by 2. So sine x plus 2a common, you'll get 1 minus cos 2x, right?
Yes,
What
sir.
is 1 minus cos
That is
2x?
2
Tell me.
cos 2 sine square x.
2 sine square x, and over here we have got 2 sine x, sine 2x into sine x. Okay, sine 2x, further it can be written as 2 sine x cos x, right?
Yes, sir.
So it will become 4 sine square x cos x plus 2a, 2 to the 4, a sine square x. Okay. I think sine square x and 4 will be common. 4 sine square x is common. We'll get a plus cos x. Then this should be greater than or equal to 0, right? No, this is all anyways greater than or equal to 0. This implies a must be greater than or equal to minus cos x. Right, tell me. Now, what is the maximum value of minus cos x? 1.
One.
This implies a belongs to closed 1 to infinity. Tell me, is it clear?
Yes, I know it is clear.
Very simple. If you have any doubt, you can ask me. Okay. See, these kind of questions can come in means. Next, question number 4. F of x equal to 2 minus 3x minus 4x cubed. Solve the inequality. Solve the inequality. 2 minus f of x, 2 minus 3 f of x minus 4 f of x whole cube is greater than f of 2 plus x. Solve. Question number 5. If f of x equal to integral from x squared to x cubed dt by ln t for x greater than 0 and x is not equal to 1, prove that the function is monotonic. Proof problem, you have to send me the whole solution. Solve. Okay, let me solve this inequality, everyone. See, there is a
Sir,
result
wait,
here.
I'm sending.
Okay, send. Is Devang right answer? Okay, let me solve. Onini, Raktim, Sarthok, Memel, pay attention. So over here, what have I got? I've got f of x is equal to 2 minus 3x minus 4x cubed. Can you people see a resemblance between the expression given on the left hand side and the expression f of x? Is there any resemblance? Tell me, everyone. Tell me on.
So it's f of x.
It's f of x, right? Basically, we have to solve this inequality. LHS is f of x. Okay. And RHS is f of 2 plus x. So we need to solve this inequality. So you need to remove one f. Okay, everyone? Now see, everyone, what is f dash x? F dash x is equal to minus 3 minus 12x square. Okay, which is of course less than 0. So if f dash x is less than 0, can I say that f is decreasing? Tell me, everyone. If f is a decreasing function, if f is a decreasing function, what is our inequality? Inequality is inequality is f of x greater than f of 2 plus x. Okay, now if the function is decreasing, okay, this implies f of x will become less than 2 plus x, if you can understand. If f of x is less than 2 plus x, this implies 2 minus 3x minus 4x cubed must be less than 2 plus x. Now you see 2 gets cancelled. You can take x to the left hand side or everything to the right hand side. You'll get 4x cubed plus 4x must be less greater than 0. And this always happens. No, not always. Take 4x common, you'll get x square plus 1. X square plus 1 is always greater than 0. This implies x should be greater than 0. Tell me, Devatri, Onini,
Yes, sir.
Raktim, Memel,
Yes, sir.
Sarthok, are you getting?
Yes, sir.
If you people have understood, solve 5 quickly. So let me solve, everyone. So what do we need to use for differentiating? Tell me, everyone. We have to find out f dash x, right? What do we need to use? Hello. Tell me, everyone. What do we need to use? While differentiating, we need to use Newton-Leibniz. Right, tell me. Hello. Tell me, everyone. Are you people getting? F dash x will be equal to 1 upon ln x cube into 3x square. Right, you people remember the rule, right? Minus 2x upon ln x square. Tell me, Memel, Sarthok, are you
Yes, sir.
getting? Okay. Taking ln x, okay, wait. Let us simplify this. Over here, x is greater than 0, or x is greater than 0. So no problem. See, this will become 3x square upon 3 ln x minus 2x upon 2 ln x. So 2, 2 gets cancelled. Over here, 3, 3 gets cancelled. Taking ln x as LCM, numerator would be x square minus x, which will give us x into x minus 1 upon ln x. Okay. Now there will be two cases. Case 1, when x is greater than 1. When x is greater than the 1, then there is no problem, right? F dash x will be greater than 0. Then there is no problem. Case 2, when x is lying between 0 and 1. In this case, ln x is positive or negative? Tell me. You people tell me. When x lies between 0 and 1, ln x is positive or negative? Tell me. Hello. Am I audible?
So negative.
Negative, right? And x square minus x, that is x into x minus 1, positive or negative? Tell me. Between 0 and 1,
Negative.
negative. Negative by negative will become positive, right? Tell me. F dash x is actually negative by negative. This will become positive,
Yes, sir.
right? Therefore, f is increasing. If you people have any doubt, you can ask me now. I'll explain. Okay. So it is monotonically increasing, whatever value of x you take in the domain. Tell me, Devatri, Memel, are you getting?
Yes, sir.
Yes, sir.
Sarthak, is it clear?
Yes, sir.
Okay. Our next topic is greatest and least value of a function. Greatest and least value of a function. Okay. Number one, where does it occurs? Occurs at occurs at dy by dx is equal to 0, or dy by dx does not exist. Okay. And end points of the interval. Sometimes at end points of the interval. Case 1, in these cases, we'll get dy by dx equal to 0. That means if the function is differentiable. But in case when the function is non-differentiable, over here dy by dx does not exist. Next, in the third case, when you're not getting a local maxima or local minima, then the function looks somewhat like this.
Sir, can you show the second point once?
Hmm.
Okay, sir.
This is case 3. Okay. Over here, you'll get the least value at x equal to a. Over here, we'll get least value at x equal to a and maximum value at x equal to b. Is it clear to everyone? Next, if you people have understood, Let us solve some more problems. Question number 6. Find the maximum and minimum value of f of x equal to e to the power x square minus 4x plus 3 in closed minus 5 comma 5. Solve. Question number 7. If y is equal to integral from 5 pi by 4 to x 3 sin t plus 4 cos t dt, find the greatest find the greatest and the least value of y in 5 pi by 4 comma 4 pi by 3. Start solving, everyone. Question number 8. If mod of a minus 1 plus mod of b minus 1 is equal to mod of a plus mod of b is equal to mod of a plus 1 plus mod of b plus 1, find the minimum value of find the minimum. Okay, Sarthak, check your answer again. I think maximum value you wrote it correct. Let's see. No, you are making some mistake. Find the minimum value of mod of a minus b.
Sorry, question number 7 is the upper limit of the integration x.
X. Okay. So I think Devank has sent some answer. Let's see. Yes, Devank, your answer is correct. So should I start, everyone? Tell me.
So one,
These are all easy problems only, not that tough. Yes, Debatari, your answer is correct. Memel, check your answer again. Ondini, your answer is correct. Okay, Sarthak, maximum is correct. Minimum, you are making some mistake. Tell me, should I solve, Sarthak?
so 1 minute.
Okay, solve quickly.
So you can solve.
Okay, let us start. So, Sarthak, what do we need to do? We need to differentiate, right? To understand what is happening between -5 and 5, right? Tell me.
Yes.
So, Sarthak, what is f dash x? Tell me.
E to the power x square minus 4x plus 3 into 2x minus 4.
Into 2x minus 4. So, we need to see what is the sign change, where it is increasing, decreasing, right? At what value of x it will, we will get a critical point. Tell me.
So 2.
Where 2.
Sir,
Before 2, it is increasing or decreasing?
sir.
Yes, Devang, tell me.
For question number 7, the will the least value can the least value come in terms of roots?
Maybe. Yes, tell me, Sarthak.
Decreasing.
Before 2, it is negative. After 2, it is positive. Right.
Yes.
So at 2, we'll get maxima or minima? Tell me.
Minimum.
We'll get minima, right? So let us
Yes.
find out what is f of 2. F of 2 is equal to e to the power 2 square minus 4 into 2 plus 3, right? This will give us e to the power minus 1. Right. So this is the minimum value. Right. Tell me, Sarthak. If you're not getting, you ask me. I'll explain. Now let us check whether the maximum will be at f of 5 or f of minus 5. F of 5 is equal to e to the power 5 square minus 4 into 5 plus 3. That will give us how much? E to the power 8. And what is f of minus 5? F of minus 5 is equal to e to the power minus 5 whole square,
48.
e to the power 48. So you can understand which one is maximum and which one is minimum. E to the power 48 is maximum.
Okay, so for here we have to find the like the changing sign changing point.
Yes, we have to understand where you are going to get minimum, maximum, right? Tell me. At local minima, we'll get minimum. At local maxima, we'll get maximum. Right? If there are more than
Okay, sir.
one local, if there are more than one local maxima, you have to find out the value at both the points, and then you have to compare. Start telling me number 7, 8, everyone. Start. Yes, Devang, your answer is correct. Devatri, you need to find out the least value in 7.
Sir, I sent the greatest value is 0. I'm
Hmm,
solving for the least.
hmm. Greatest is correct only.
So can you please show question number 8? Okay, so done.
Yes, Devank, you were saying something.
No, sir, I was not saying anything.
Okay. So I think I should solve for number five.
So
Anyone who's
1 minute.
Okay, okay, okay. I think yes, Devatri, have done it correctly. Let's see. Yes. No, Devatri, I think there is no, no. It's correct. It's correct. 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 Okay. On any, let me see. See, this kind of question do come. You see, PYQs in JEE means you'll get it. This kind of questions. Yes. On any, your answer is correct. So who is left? I think Mabel and Raktim is left. So Mabel and Raktim. Email, are you still there? Oh, she left or what? Hello, Mimel and Raktim. Should I solve?
So one second.
Send quickly. These are all easy problems. Easy 4 marks you can receive. You can score easy 4 marks. No, I think you are making some calculation mistake, Raktim. Email, check your answer again. Okay, Nini, check your answer again. Email, your answer is correct. No, Sarthak, you are making some mistakes. So, Sarthak, should I start? Tell me.
So you can start.
Okay. So, Sarthak, again, we need to differentiate, right? While differentiating, what do we need to use? Tell me, Sarthak.
The f dash x by f of x minus.
No, 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 no. Newton Leibniz, right?
Yes, sir, the previous one.
Yes. So what will it become? It will become 3 sine x plus 4 cos x multiplied by dy dx of x. That is gone. Minus 3 sine pi by 4 plus 4 cos pi by 4, 5 pi by 4 multiplied by dy dx of 5 pi by 4. That is 0 only, right? Tell me, this is y dash. Tell me, are you getting Sarthak? Yes or no?
Yes.
Now, Sarthak, over here, in the range of 5 pi by 4 to 4 pi by 3, I mean, 5 pi by 4 to 4 pi by 3, these are angles in the third quadrant, isn't it? In the third quadrant, both sin x and cos x is negative, right? So this
Yes.
implies y dash will be less than 0, isn't it?
Yes.
For x belonging to 5 pi by 4. comma 4 pi by 3. Tell me, anyone having any doubt, you can ask me. Okay, so it's a decreasing function. So the maximum value will be at the minimum point and minimum value will be at the maximum point, right? So what is y max? Y max will be equal to integral from 5 pi by 4 to 5 pi by 4. Oh, can you see upper and lower limit is same? So this value will be equal to what? Tell me. Upper and lower,
0.
0. And what is y minimum? Y minimum, we have to calculate the integral 5 pi by 4 to 4 pi by 3, 3 sin t plus 4 cos t dt. This will give us minus 3 sine plus 4, sorry, minus 3 cos plus 4 sine. You have to substitute from 4 pi by 3 into 5 pi by 4. So substitute, when you substitute 4 pi by 3, what will you get? Tell me. What is cos 4 pi by 3? Tell me. Tell me what is cos 4 pi by 3?
Minus half.
Minus half. So this will become 3 by 2. And what is sine 4 pi by 3? Root 3 by 2, right? So minus 4 root 3 by 2 minus, when you substitute 5 pi by 4, this will be 3 by 2, 3 by root 2 minus 4 upon root 2. Rest, what will you get? 3 by 2. Now 3 by root 2 minus 4 by root 2 will give us minus 1 by root 2. So you are getting plus 1 by root 2 minus 4 root 3 by 2. Is it clear, Sato? Tell me. Hello, Sarthak, have you understood?
Yes, sir, please.
And Raktim,
Yes, sir.
tell me, should I solve the eighth one? Tell me, should I solve?
Sub 8.
Sir, in the seventh question, we do not have to find any critical point.
No, you just have to use a function. See, it is looking like a function. Similar kind of function is there. No, Andoni, you are making some mistake.
No, so like in the last question we solved, we do not have to find any critical point.
Over there, there was no critical point only because f dash x was coming less than 0,
Okay, sir.
right? It's coming less than 0. So it is always decreasing.
Okay, sir, understood.
So can you please solve it?
Okay, let us start. Over here, everyone pay attention. It is looking like mod x plus mod y, right? Tell me, everyone. Are people getting? So over here, I'm going to take one function. Over here, I'm going to take one function. Let f of x equal to mod of a, or wait a minute, mod of x minus a plus mod of x minus b. Tell me, Sarthak, Devatri, Memel, Devang,
Yes,
are
sir.
the people getting?
Yes, sir.
How, how does the graph looks like? Graph will look somewhat like this. Right, tell me. Sarthak, graph looks somewhat like this. Yes or no? No. Sarthak, are you there?
Yes, sir. Understood.
Now see, in the question it is given that f of f of 1 is what? F of 1 is mod of 1 minus a plus mod of 1 minus b. F of 0 is what? F of 0 is equal to mod of a plus mod of b. And f of 1 is what? Sorry, f of -1 is equal to mod of a plus 1 plus mod of b plus 1. All these are same, right? Tell me. All these are same. F of 1 is also same. F of 0 is also same. I mean, it has the same value. And f of -1 is also has the same value. Okay. So from here, can I say, see, from here, can I say that a is less than or equal to -1 and b is greater than or equal to +1? Yes or no? Tell me. So what is the minimum value of a minus b? Okay. For the minimum value of a minus b, therefore minimum value of a minus b will be equal to mod of -1 -1, right? Which will give us mod 2. I mean 2 only. Tell me, is it clear to everyone? Andini, Sarthak, Raktim, Devang, are people getting?
Yes, sir.
Okay. Let us solve some problems on inequality. Question number 9. Inequality. Prove that tan x is greater than x. Using calculus, you do it. Before, I have done it with limits, if you people remember. I have done it with geometry also. You have to prove that tan x is greater than x for x belongs to 0, comma pi by 2. Prove it. Okay, let us start. How we can prove tan x is greater than x using calculus? What you do is, you take f of x is equal to tan x minus x. Over here, you take f of x equal to, let f of x equal to tan x minus x. Then what is f dash x? F dash x will be equal to 6 square x minus 1. Now what is 6 square x minus 1, everyone? Tell me. Tan square x, right? And tan square x is always greater than or equal to 0. And over here it is strictly greater than 0. This implies, can I say that f of x is an increasing function? Tell me. Hello. Can I say that f of x is increasing?
Yes.
And if f of x is increasing, what is f of 0? F of 0 is equal to 0. And f of 0 is equal to 0. And since f of x is increasing, this implies f of x is greater than 0 for all x belongs to 0 comma pi by 2. Right, tell me. Sarthak, are you getting? Sarthak, Onini, Raktim, Devang, are people
Yes.
getting? This implies, Devatri, are you getting? Tan x minus x must be greater than 0.
Yes, sir.
This implies tan x is greater than x. Yeah, anybody having any doubt, let me know. Tell me. Memel, you understood?
Yes, sir.
Okay, if you people have understood, let us do another one. Question number 10. If f of x equal to minus x cube plus b into b plus 3 for all x greater than or equal to 0, less than 1, and 2x minus 3 for all x greater than or equal to 1, less than or equal to 3. Find b if the smallest value, if the smallest value occurs at x equal to 1. Solve. Question number 11. Find the minimum value of 8 to the power x plus 8 to the power minus x minus 4 into 4 to the power x plus 4 to the power minus x. If x is greater than 0, f of x equal to 5x cubed plus a by x to the power 5, where a is greater than 0 is a constant. Find the smallest a. Find the smallest a such that f of x is greater than or equal to 24 for all x greater than 0. Yes, Devank, right answer. Tell me, should I solve, everyone? Email Devatri or Nini, tell me, should I solve?
Sir, send it.
Send, send. Yes, on any right answer. I want everyone to solve. Sarthak, also send your answer.
Yes, sir, solving.
There's a slight mistake, Raktim. And Memel, are you solving? Are you sending your answer?
Yes, sir, sending.
Send quickly. Yes, Devatri, right answer. So only Sarthak, Memel, and Raktim is left. Memel, what is this? Check it again. Only two values.
Sir, question number 10.
Only two values. Yes, Raktim, it is correct. So Memel and Sarthak, I'm solving. Okay,
Sir,
pay
one
attention.
minute.
Okay. Yes, Memel, right answer.
Sir, you can solve. Sir, can you please solve it?
I'm solving. Pay attention. Hello, Devatri, can you hear me?
So,
Devatri, these are the three last problems. Okay.
oh, okay, sir. Then I'm still.
Okay. They are the last three problems. Tomorrow there will be a normal class from 9 to 11. Okay. What is f dash x?
Sir, actually, tomorrow maybe me and Abhiksha both will not be able to attend because the next day there's chemistry. So,
Next day is chemistry.
yes, sir.
Okay. For x greater than or equal to 0. How was your maths exam?
Sir, it was good, much better than 11th.
Okay, much better than 11th.
Yes, sir.
Okay. How much can I expect from you? Tell me.
Sir, I think um, above 34 to 37, I'm expecting in that range. Like I
Out of?
left out of 40.
Oh, then it is okay. I thought out of 100 you're saying. I got scared.
No, no, sir. No, sir. No, sir.
Okay. Just to see, since over here f is decreasing in the interval, right? F is decreasing. in closed 0 comma open 1 and increasing in close 1 comma 3, right? Tell me, Sarthak. So the Sarthak, over here there can be three cases, right? Remember the initial part of the class. In the initial part of the class, I gave one problem, right? If it is increasing in one part, decreasing in one part, we cannot say that one at one we'll get local minima or local maxima, right? Three things
Yes,
can
sir.
happen. This is one thing, right? 2x minus 3. This can happen, right? This is one case. Right, tell me, everyone. This is one case. Case two. So, Sarthak, you have to identify which case will be the correct one. Which case or cases will be the correct one. This is another case at x equal to 1. And there can be another case where the function becomes continuous. Right, tell me according to B. So, Sarthak, which cases are
So
in which case
case two will be applicable.
case 2 will be applicable?
So
Tell
for
me.
local minima, right?
Local minima. Case 2. Anyone else? Tell me. Case 2 is applicable or something else? Tell me. Memel, you have solved this problem. Tell me, Memel, which case is applicable? In which cases or case you'll get local minima at x equal to 1? Tell me,
Sir, I think
Memel.
case 2 is possible.
Case 2 is possible, but you have solved the problem correctly. So you should be able to identify, isn't it? Jadabatri, you think? Tell me which case or cases are possible. Raktim, tell me which case or cases are possible. Devang has also solved it, right? Devang, tell me. Devang is there.
2 and 3.
So
Cases
two
2
and
and
three.
cases 2 and 3, right? Memel, what happened? How did you solve the problem if you cannot identify the case?
Sir, I said case 2 and then case 3 is also possible. Then others told, so yes, I understand.
No, what I'm saying is, first of all, you said case 2, right? Tell me. Hello.
And I thought,
First of all, you said case
yes,
2. Now, when everyone said case 3, then you are saying case 2 and case 3, isn't it? Tell me.
sir, I thought in the middle.
In the middle. Acha, pay
Sir,
attention. F of 1 minus should be equal to f of 1 plus should be equal to f of 1, right? This is for case 1. I mean, case 2. And for case 3, what do we need to apply? F of 1 plus should be less than f of 1 minus. Right, tell me. Right, Sarthak. Okay. So what are we getting? Minus 1 plus b into b plus 3 must be greater than or equal to 2x minus 3. So from here, sorry, 2 into 1 minus 3. So minus 1 will get cancelled. B into b plus 3 must be greater than or equal to 0. This implies b belongs to minus infinity comma 0 closed union, sorry, minus 3 closed union 0 comma infinity 10. If there is
Sir, I
anyone
got
having,
this answer, but I thought it will be wrong.
no, 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 this is the correct answer. Number 11, should I solve? Tell me, everyone. Let me solve 11. See, both are functions in 2 to the power x plus 2 to the power minus x, right? So what you do is you take a parameter. You take, acha, over here y is equal to this. Okay. You take t is equal to, let t is equal to 2 to the power x plus 2 to the power minus x. So everyone, t square will be equal to 4 to the power x plus 4 to the power minus x plus 2, right? This implies t square minus 2 is equal to 4 to the power x plus 4 to the power minus x. And can everyone tell me what will be 8 to the power x plus 8 to the power minus x? We have to cube it. T cube will be equal to 8 to the power x plus 8 to the power minus x plus 3t into 3t into 2. Right, tell me everyone. So what will be y? Y will be equal to t cube minus 3t minus 4 into t square minus 2. Right, tell me. Sarthak, are you getting?
Getting.
Sarthak, Memel, Devang, Andini, are people
Yes, sir.
getting?
So repeat
Devatri, are you
So
again.
could
getting?
you please explain this once again?
Yes. See, if I take t is equal to 2 to the power x plus 2, because see, both are powers of 2. Right, tell me. I have to convert them into
Yes,
a
sir.
single variable. So t square is equal to 4 to the power x plus 4 to the power minus x plus 2. T square
Yes, sir.
minus 2 is equal to 4 to the power x plus 4 to the power minus x.
Yes, sir. Okay, sir,
So
got
t,
it. Then T
got
cube
it.
we have
Using cubic
got.
formula.
Yes, sir, got it.
Now, one more thing. Can anyone tell me the range of t? T belongs to. Can anyone tell me the range? You people can understand that this is 2 to the power x plus 1 by 2 to the power x. What is the range? Tell me. How to find out the range of these kind of expressions? 2 to the power x plus 1
Say
by 2 to the
GM
power x.
equal to GM.
AMGM, right? If you apply AMGM inequality, what will you get? What is the minimum value? Tell me. What is the minimum value?
Say 2.
2. So can I say t belongs to 2 comma infinity? Tell me, Sarthak, Devang, Onini, Memel, Debatri, you people understood t belongs to 2 comma infinity?
Yes, sir.
Yes, sir.
Oh, okay. So over here, y is equal to this. Okay. Y dash will be equal to 3t square minus 3 minus 4 into 2t. What will we get? We'll get 3t square minus 8t minus 3. We can factorize it. This will become 3t plus 1 into t minus 3. Okay. Critical points are minus 1 by 3 and 3. Right, Sarthak, are you getting?
Getting.
This is how the quadratic is going to look like. So can you people understand that y is decreasing? Y is decreasing in 1 by 3 comma 3. Right, tell me.
Yes, sir.
Wait, it should be minus 1 by 3. Okay. Y is decreasing. Acha, but t has a range, right? T belongs to 2 comma infinity. So this is to always positive, right, everyone? So we don't need to think about this. We need to think from 2 to infinity. So y is decreasing in 2 comma 3. Are you people getting why did I take 2 comma 3?
Sir,
Because
please explain once more.
yes, Devang, range of t is 2 comma infinity, right? Tell me.
Yes, sir.
So why will you take any value below 2? Below 2 we shouldn't take, na?
Yes, sir.
T belongs to 2 comma infinity. Into in the range 2 comma infinity, this is always positive. And where it is
Yes.
increasing? Increasing in 3 comma infinity. So I can say that 3 is a point of local maxima or minima. Tell me. If it is decreasing in 2 comma 3 and increasing in 3 comma infinity, So t equal to 3 is a point of local maxima or minima. Tell me everyone. Decreasing then increasing. What happened everyone? Exhausted? Tell me Sarthak or Nini, anyone tell me.
Sir, minima.
Minima, right? What happened everyone? Or Nini, are you there?
Yes, I'm there.
F of 3 is equal to 27 minus 3 into 3 minus 4 into 3 square minus 2, which will give us 18 minus 4 into 7, which is minus 10. Tell me, you people understood? Yes or no? Hello? Do you
Yes,
people
sir.
understand? Okay.
Yes, sir.
Acha, this is the last one. Will you do it as home task for tomorrow or should I solve it now only? Tell me. Hmm? Or should I solve it now? Tell me. Or you people will try this at home? Tell me.
So we'll try it.
Try at home. Okay, this problem I'll discuss it tomorrow. Okay. And the Devatri, you also solve it and send it. Okay. Since you are not joining tomorrow's class. Number 12, I'm going to discuss tomorrow. Okay. Since you people are exhausted. Okay. So I think everyone, we can keep it till now. Next class will again continue. Thank you, everyone, and good night.
Okay,
Yes.
sir.
Thank you, sir.
Yes.